Hey folks, this is James. Welcome to another tutorial. This time around I'm going to show you how to essentially redo one of my older tutorials on looping rings I did last year in 2.93. Quite a different workflow in 3.0. So anyone that's done that might be interested to see how it's now done in 3.0 with the field system. Essentially you've got a bunch of looping rings and you can change the offset to change the timing of the rings, as well as do things like changing the axes that they're on. You can get all three axes in there. And this is a looping animation. So you can do things like change the offset and you get different results. You can also change the frame range. So if I wanted that on 100 frames, now I've got a 100 frame looping animation. So let's make a start on the tutorial. Let's start off with a cube and add a new geometry nodes network. Delete that first node. The first node we want there is curve primitives, curve circle. Put that into the output. Just going to change the resolution of that to 128. Now I want to duplicate this 10 times. So the easiest way to do that is mesh primitives, mesh line, put that into the output instead. You can see you get a line going from 000 up to 001. So if you change that to a 0, it means essentially you got 10 points all overlapping each other there. And it's just a matter of instance on points. And then just put in that curved circle into the instance. So you've actually now got 10 circles there. Because they're all the same scale, you can only see one. So input, index. Each of those instances has an index. So if you look at the spreadsheet, you'll see each of them 0 to 9. So if you use that to put into the scale, you can see you get those concentric rings. The only problem with that is the first one is actually on a scale of 0 because the index is 0. So if you use a math node and add 1 to that and look at the scale, now you can see that the first one is index of 0, it's got a scale of 1. Etc. all the way up to 10. So that's why we're adding 1 to that. So now I want to give that some thickness. So curve to mesh. And you'll notice that they've disappeared. So what you want to do before that is realize instances, and what that's doing is joining them all into essentially one giant curve. So now we're just going to put in a profile curve into that, and you can do the same thing there, just another curved circle, resolution of 16 and radius of 0.4. Okay, so now we've got all our rings. It's just a matter of putting in the animation. So I'm going to use the rotate instances node after the instance on points. And you rotate that on the x-axis. You see they're all rotating. So to start with, I want to get access to just that x, because this is a vector, so we want to split that out into the three components. So vector combine, pipe that in. Now you've got a socket there for x, y and z. So I'm going to drive this all with time. So get your value node there, type in hash frame. If you happen to be doing this in 3.1, there is a dedicated node for this now. So that value, just put that straight into X. See, it does rotate it, but that's obviously not what you're after. So I'm going to change the frame range from 0 to 239. So that gives 240 frames. And at 30 frames a second, that's an 8-second loop. So I want this to rotate over 360 degrees. So what I'm going to do is math node, I want to divide this frame number by the number of frames. So you put in there 240, because remember we've got a 240 frame range there. So what that's going to do is essentially give a 0 to 1 output. So when it's at frame 0, this will be 0, and it'll be 1 by the time we get here. And rather than add, what I meant there was divide. So you can see it's not getting even 90 degrees. It's because when you split out that rotation, it's actually using radians. So radians are just a different way of describing a rotation. And so to get this to do what we're after, we need to map that range. Because as I said, that's coming out from that divide between 0 and 1. So if we map that range, 0 to 1, 0 to 360 degrees. But because this is in radians, we can either say TAU, tau. So that's basically 2 times pi. So you'll see that does rotate 360 and then loops. But if you don't understand this, it's just as easy to create another math node and say conversion to radians. Put that into the to max and type in 360 there. And that does the same thing. So you put that on 720, it would go around twice in that frame range. I'm going to stick to 360. Alright, so how do we get these to offset? Because they all have that 0 to 1 coming in, I want to be able to offset that for different rings. So what I'm going to do is duplicate that. So you get a second math node there and change that to add. And we're going to add in that index. Now notice that we don't have the instances anymore, because after you use this realize instance, they all change into basically a mesh. If I muted that, you can see the instances are back there, 10 instances. But because we're using all of these math operations before that realize instance, Blender knows that that index is referring to exactly what it was here, basically the number of the instance. Duplicate that index node and pipe that into the add. Now it does do something there initially, but the problem there is that's adding in values that go over the 1. And remember, we're trying to keep that 0 to 1 range, which is then being remapped 0 to 360. Need one more node there and put the fraction on there. So that means the value coming out of here is clipping off the bit before the decimal point, and you're only getting the fractional part. So in other words, it's still staying between 0 and 1. But they're all going at the same rate. So the way we're going to get around that is to do two more things there. Just going to make a bit of space. I'm going to put a color ramp here. So color ramp, and put these knots a bit further in. And then the last thing I want there, because these indexes are whole values, as in 0, 1, 2, 3, 4, etc., I'll turn that into a fraction. So math, multiply that by 0.11. And I actually did make one mistake there. And I should have that color ramp before the map range. Okay, so now we're getting that correct effect. The reason that didn't work is that, remember, this is 0 to 1 coming in and 0 to 1 coming out. So now you've got that set up, you can change this value to get different results. 0.33. So put that, say 0.99, the closer those rings will be together. You can see that the offset is such that the rings rotate almost at the same rate. And this gap here determines how long they sit there for after the rotation. Probably want to really change that to an ease. And then you get it easing back in and easing out of the rotations. I'm going to put that back to 0.11. Okay, so lastly, just going to put a bit of colour onto this. And make sure you've got that in the material preview. And so to put material onto this, there's essentially one large object now, one single object. So material, set material, put in the default material, and so that's just the default material. But how do we actually edit that material? You need to have it on something. So if you put that on the network itself, even though that isn't applying, it's actually the node that's doing it, just to show you that. Just base color, just change it there. If I mute that, you can see it's gone. So you need to apply the material with the nodes themselves. So I'm just going to do a very simple color ramp so that looking at the distance, it's going to color based on the distance. So what you want there is geometry. The position of each point in space on the mesh to the center of the world. And we want vector math. Get the distance from the position to 0, 0, 0. And it's just a matter of running that through a color ramp. Okay, so you're not really seeing anything there. The reason for that is the distance is actually at 0 to about 10, a little bit over 10. And so this color ramp is only taking in 0 to 1 range, so we need to remap that. Map range, and change that to 0 to 10. So you start to see a bit of the color ramp there. You're just going to change that to 15 to get a bit more of it. I'm going to put in a third knot in the middle and make these colours orange, red and pink. As you can see, that correlates the distance to that colour ramp. And then finally, just going to put that into Eevee mode and make the colour of the background a pure white. Ambient occlusion on 3 and 3, and screen space reflections on. Hide everything in the viewport, and that's the final result. One last thing you may want to do is take all of that math operation there for the time, grab all of those nodes and do a Control G. That neatens it up. It also means you can put some parameters on the front of this. We call that time. So if I came in here, the main two are these ones here. So this is the number of frames, and this is the offset. So I'm just going to give them better names. I'm going to call that frame range and time offset. So that time offset, we just want 0 to 1 range, and the frame range doesn't really matter. You could say 0 to 500. And so now if you wanted to change that offset, you can do so there. And if you want to change that frame range, so if you wanted to loop between 0, 99, so 100 frames, you put 100 in there. Okay, so that's the end of the tutorial. As usual, I'll have the project file available for download for Patreon subscribers. And on Patreon, I'm also doing a tutorial a week, as well as posting other project files. Thanks for watching.